In Unit 4 of Physics, you have been learning about the three different ways of heat transfer by conduction, convection, and radiation. The third one, radiation, is basically transfer of energy by the means of electromagnetic waves, which is basically light. Now, electromagnetic waves have there's a large spectrum, all the way from gamma rays being the shortest wavelength or highest frequencies, to radio waves and TV waves on the other side of the spectrum being very long and having much lower frequencies. But when we talk about heating through light, we usually are considering the part of the spectrum which we call infrared light, which is just below the visible light, so below the red part of the visible light. The PhET simulation on greenhouse effect is a good way to demonstrate both what greenhouse effect is, which is a big talk these days because of the climate change through which the planet is going. So it will help you to understand what greenhouse effect is. As well, it will help you to understand how greenhouse effect happens and why it happens, and it has everything to do with the absorption and emission of infrared light by the gas molecules in the Earth's atmosphere. And as a part, or what you will be doing in this assignment, you're going to upload a file in which you will basically use PhET simulation to figure out which of the greenhouse gases that this simulation is actually allowing you to play with, which of them is the most efficient greenhouse gas, so which of them is the best absorber of infrared photons. And you already know that the ones that are the best absorbers, they're also the best emitters, because if an object is a good absorber, it's also a good emitter of infrared light. So black objects get warm faster during the day, but they also get colder, or they got cold faster during the night. Enough about that. Let's consider what's happening on the screen. So the yellow photons are coming from the sun, and they are the visible photons. So these are the visible light that you see. The red photons, you can see that there are no yellow photons going up, but there's a lot of red photons going up. These are the infrared photons that are emitted by the Earth. So when a yellow photon, let's pick a yellow photon, follow this yellow photon, when it gets absorbed by the Earth's surface, almost there, okay, right there, it disappeared. So it's no longer a visible photon. It was absorbed by the Earth's surface. It warmed up the surface of the Earth a little bit, and then it gets re-emitted. You remember that the color of the photons, or the type of light an object emits, depends to the surface temperature of that object. And so the sun being much warmer than the Earth, it's actually hot enough on the surface to emit visible light, whereas the Earth's surface is kind of cold compared to the sun's surface, and the most energetic photons emitted by the Earth are, they are in the infrared part of the electromagnetic spectrum, and here in the simulation they're showed by these red. So I mean, you don't see the photons emitted by the Earth. You feel them as warmth. If you've ever been in a place where there's a lot of concrete, a lot of stone, if it gets warm during the day, so if it gets very, very heated in the summer, and then after the sun goes down and you're close to that concrete wall that was on the hot sun the whole day, you can feel the warmth radiating from that wall, and you can't see it, but it's still light, just not in the part of the spectrum that your eyes are built to see. It's in infrared. So these red photons are infrared photons that are emitted by the Earth. But follow these infrared photons and see that there's something strange that's happening. So you can see that it's moving up, but then it jumps and goes back down, and then it can jump and go back up, and this jumping might continue, and eventually these infrared photons leave the atmosphere. But you can see that many of these again jump back, but some of them actually go up and they leave the screen. So those are the ones that actually leave the atmosphere. So what's happening? Why are these infrared photons sort of jumping around here in the atmosphere? What is it seems like they're bumping into something, and sort of if they were reflecting back. They're not bumping, they're not reflecting back. They're actually being absorbed by the molecules of gas in the atmosphere, and that's going to be shown here in this tab over here. So you can choose from different molecules. I guess there are 5 molecules to choose from: methane, carbon dioxide, water, nitrogen, and oxygen. And you can send either visible photons or infrared photons at these molecules. And you can observe that some of these photons just pass right through, but some of them, let's take a carbon dioxide molecule, some of them get absorbed by the molecule, and then the molecule vibrates, and then it emits that photon out. And the important thing here to notice is that the emitted photon is not emitted in the direction that was the original direction in which the photon was flying. The emission of the photon can happen in any particular direction. And so when these infrared photons get absorbed by the gas molecules, not all of them are re-emitted back toward the surface of the Earth, but some of them are. And those are the ones that basically warm up the Earth's surface more than what the surface temperature would be due to just the photons that are coming from the surface of the sun. So it's kind of like if there was some kind of an invisible layer in here, invisible mirror, into which these infrared photons are bumping, and they're going back toward the Earth. And that's what we call a greenhouse effect. So you can choose in here in the settings the different concentrations of these greenhouse gases. This is for today, but you can go back to 1750, which was, I think, called the middle, like small ice age, when the surface temperatures were, I think, smaller than what they are today. And then you can even go to an ice age. Notice that in the ice age option, there's snow lying on the ground, and some of the visible photons that hit the snow, they don't get absorbed, but they get reflected back and leave the atmosphere. And so if you have a big snow cover on the Earth, then it's really hard to warm up the surface of the Earth, because these photons, these yellow photons, visible photons, don't get absorbed by the Earth's surface. They just get reflected and leave. They never get absorbed, and they never heat up the surface of the Earth. So you can get into a sort of runaway. Just like we have a runaway greenhouse effect, there's also a runaway ice age effect. Anyway, here's what I want you to do. I want you to figure out which of these 5 gases is the most efficient greenhouse gas. And to do that, I want you to send 50 infrared photons toward the 5 molecules, and I want you to count how many of those 50 get actually absorbed and emitted by the... I mean, everyone that gets absorbed gets emitted, but not every infrared photon that is fired toward the molecule gets absorbed. And so to get at least some good idea about how effective these gases are, I want you to do 50 photons, and you can do either in sets of 10. So you do 10 for methane, 10 for carbon dioxide, 10 for water, and so forth. Or you can do just straight 50. So 50 for this, 50 for this gas, 50 for water, 50 for nitrogen, 50 for oxygen. And based on those numbers, I want you to formulate which of these gases is the most efficient greenhouse gas. And if you could also then check this online, so find some website on which you can on which they tell which of these gases are the best, or the, I guess, worst in this case, greenhouse gases, which of these contributes to the greenhouse effect the most, and then compare whether their answer is the one that you got from your numbers from the PhET simulation. Because I don't know whether the simulation, the programmers that are making the simulation, whether they actually checked which of these gases is the best at absorbing infrared light. I would guess that that's what they would do, but maybe they didn't. So I want you to check whether what you can find on some website, whether it actually, how it is compared to with the numbers that you get from the PhET simulation, and then upload your answers and include the source to which you will be comparing your results.